Right, so good evening everybody.
Good evening.
We'll be doing review first and then we'll get moving doing some more graphing on equations today. So first I just want to do the review. You guys said I have 5, 6, 7, and 8 from page 363. Ahmed, you said you had some trouble ones.
Yes.
Any others?
3, 5, and 7.
3, 5, and 7. Okay, so 3 as well. Alright, no, we'll go through it. Noah, did you have anything you wanted to add to those?
I think I already do.
3, 5, 6, 7, 8.
Yes.
Okay.
The other thing is that there is formula x equal minus b plus minus
Oh yeah, there's
z.
formula for quadratics.
Yes, the implementation I actually used to, but it sometimes comes like to implement it, sometimes get into trouble.
Okay.
Yes.
Yeah, so well, I can do that. We can see if we have a little time.
Okay.
We can do some quadratic formula. And also we had some of the WhatsApp
Okay.
we didn't do last week. WhatsApp questions. Alright, so let's do these first and then we can go. Hi, welcome. Alright, so number 3 on page 363. Alright, it says the 3 packages below weigh a total of 15 pounds. That's first, second, and third. The first package weighs twice as much as the second package. The third package weighs 3 times as much as the second package. How many pounds does the first package weigh? So, one of the ways to do this is using algebra, but this one is trying to teach you to quickly use the options you have. Okay? So we have A, B, C, D. So we just basically go, if it's A, right, it's 2. So the first one is 2. That means it weighs twice as much as the second package, right?
Yes.
So first, I'll just do first, second,
Sure.
third, okay? So now this is 2, and so this is twice as much as the second package,
And like 2x.
right? So this one must be 1,
Yeah.
okay? Because this is twice as much as this one,
Yes.
right? And then the last one it says the third package weighs 3 times as much, okay? 3 times as much as the second package. So this one is 3 times this one.
So
3
that's
times
times 1.
3.
That's 3. Yes.
Yeah. And now we need to, it says altogether they weigh 15. Is this 15?
No.
No. Okay, so not A.
Yeah.
Not A. Right, then let's try B.
Yes.
Same thing. Alright?
Yeah.
B says 4. So that means this one is half of it, right?
And this is 2.
So this is 2, and what is this one then?
8.
And this one is 3 times this one.
3 times
6.
2, 6. Yes.
6.
6.
Alright, so that's 12.
12. It's not
So not
A and not
B.
B.
Okay, that was B. Alright? So not B. Now let's try C. 5. This is 5. So what is half of 5?
2.5.
Yeah, 2.5. 2.5. And so the third one is 3 times this, right?
7.5. Yes.
Did we agree 7.5? Yeah, 7.5. Now we add them up. 7.5 plus 2.5?
15, yeah.
10. This is 5. 15.
Yeah. 15 equals
Therefore, C. Right? This is how you do them. This is the easy way. The trick way without having to do the math, the algebra. Any questions on how I did that? You saw how I went through. I don't have to go to D because I've gone through already. I know from C it's the correct one. So it's C.
not
Pardon?
out of algebra.
If you were to do it algebraically, you would say the first one, this is the lowest one. So second is x. Well, let's just put, right? This will be x. This will be 2x. And this will be 3x, right?
Yeah.
And then all together they equal 15. So x plus 2x plus 3x equals 15.
Yeah. This is the way that I
This
did
is
it.
the way you should do it in algebra.
Yeah.
Right? X plus 2x is what?
3x.
Plus 3x?
6x.
6x. So 6x equals 15. This is, oh yeah, that's right. Okay, so then divide by 6, both sides,
Yeah.
right? And x equals what?
equal 15 over 6a.
Is this common 3? So this is 5.
Yes.
And this is 2, right?
Yes. 5
So
over
5 divided by 2?
is 2.5.
2.5.
Yes.
Okay, so x here. So we want the first one, right?
Yeah, exactly.
So 2x. So first
Yes.
equals 5. That's how you would solve it with algebra. But you just did kind of like, and honestly, a lot of times when I think about these problems, I solve them this way. Right? I say, even if I don't have a, even if I don't have a list of answers, I come in my mind, okay, what if it was 3? And I try to figure it out. Okay, it's not 3, it's too low. Let me try 4. Okay, it's not 4, let me try 6, too high. Or let me try 5, and then I get it. You know, so sometimes you just, even if you don't have the answers here, I still kind of figure it out in my head with like a hypothetical, what if it's this, what if it's that. Or sometimes I do that to try to get the pattern. Because after I've done this a few times, it was easy to see it was x, 2x, and 3x, right? So if you need to find it by the algebra pattern, just solving a few of them, or trying a few just numbers, will help you find the full pattern that you can use the algebra for. Alright, so that's number 3. Send that. Number 5. Nelson is twice as old as Maria. 6 years ago, Nelson was 5 times as old as Maria. How old was Nelson 6 years ago? Okay, so we should just write Nelson, I'll do N. Maria is M, right?
Yeah.
So they want to know how old was Nelson 6 years ago. So if we do A, right? A, Nelson was 5, it says, right? And so 6 years ago, he was 5 times as old. So if he was 5, and he's 5 times as old, how old was Maria?
Read the question again.
Okay, so this is 6 years ago. 6 years ago. Okay? So 6 years ago, because the question's asking how old was Nelson 6 years ago. So we have to start with that, right? Because that's what our answers are here. And then we figure from there based on the rest of the problem. So it says here in the problem, 6 years ago, Nelson was 5 times as old as Maria. Right? And it says, and then if we say, for A, it says he was 5 6 years ago. Right? Because it says, how old was Nelson 6 years ago?
10.
So if he was 5 6 years ago, how old was Maria 6 years ago?
No.
You don't know?
25.
So it says he was 5 times as old as she was.
That maybe wasn't born.
So 5 is 5 times what?
25.
No, 5 times 5 is 25. But 5 times what is 5?
1 year.
1. 1. This is the challenge. So if he was 5 times her age, and he's 5, then she was only 1.
Only 1.
Okay? It says he was 5 times as old as Maria 6 years ago. And here he's 5. So 5 is his age now. If it's 5 times, then that's, she's 1. Okay? Okay, if this is true, then now, 6 years later, we have to add 6 to each one, right?
Yes.
It's 11 and 7.
7.
And it says he's twice as old. Is 11 2 times 7?
14.
Is this true? Because this is 6 years ago, N is 5 times Maria, right?
Yeah.
Now, N is 2 times Maria. Right? So is this true? Is 11, is he 2 times Maria's age? Is 11 2 times 7?
Maybe 11 plus.
All we need to do is to find out is A the correct answer. If this does not equal twice this, then A is not the correct answer. What is 7 times 2?
14.
14. So it's not 11.
Yes.
So that means he's not twice.
Plus 7.
So it's not A. Let me do the next one, maybe you can see. Okay? So not A. How about B? Right? B, it says 10. So 6 years ago, Nelson was 10. If Nelson was 10, and Maria,
5.
11.
when Nelson 6 years ago was 5 times Maria's age. So 10 is 5 times what?
5 times 2.
5 times 2. So that means Maria was 2. Okay? Because 6 years ago, if he was 10, then this is 5 times this. So it's 5 times 2. Now, we add 6 to each one, right? 16. 2 plus 6? 8. Is this 2 times this?
Yes.
Now he's twice it, so it's B. Okay? If you want, you can test the other ones, just so you can see the pattern. Right? If we did like C is 15, then Maria would be what?
7.
7.5.
No, not half. 6 years ago.
2,
No.
3.
3. Because it's dividing by 5. Right? This is 5 times this. And then now it would be 21, and this would be plus 6 is 9. 21 is not 2 times 9. So that one's wrong. And then D would be the same. Right? It's 20. So if he was 20 6 years ago, he would be 5 times her age. So what is that? 4. That's right. And then we add 6. 26 and 10. This is also not twice. So these ones are, this is C. This is D. So the answer is B. Okay. I feel like you guys aren't fully happy with this one.
Yeah, okay, this is.
Yeah?
It,
So what you're looking at, the 6 years ago is probably throwing you off a little bit. Because the answers they're giving you are how old was Nelson 6 years ago. Not now, but the answers they give you is 6 years ago. So what you have to look at is, the question says, 6 years, he's twice as old as her now. But 6 years ago, Lifnei Shisha Shanim, Nelson was 5 times as old, right? So whatever number you get here, you have to know it's 2 things. 1, it's from the 6 years ago, and 2, it's whatever this is times 5. It's 5 times this. So you put that number under Nelson, and then you say Maria has to be, divide by 5. Because his age is 5 times it. So you say, what times 5 equals Nelson's age? So we had, if it's 5, it was 1. If it's 10, it was 2. And then we can move forward to now and add 6 years to each one. And we can check it. Yeah?
Yes.
This one's a hard one.
Is that hard one?
Yeah.
Yeah, because we don't see there is division, and when we can divide the two by 3. So
Yeah, I know. Because it's like the way that you're doing these is you're kind of thinking about them in your head.
yes.
So if you want, the way you would do this with math is basically, I would say, Maria 6 years ago equals X. Okay? And then Nelson, 6 years ago,
5.
equals 5x. That's right. Okay? And then, now that means if Maria 6 years ago is x, Maria now is x plus 6, right? And Nelson now is 5x plus 6. And now we say Nelson now is 2 times Maria now, right? So we'd say 5x plus 6 equals 2 times 2x plus 6. Like that. Right? And then I would solve for x. So I'll do that. 5x plus 6 equals 2x. And 2 times 6 plus 12. That's right. Alright. So let's move the x's to this side and the constants to this side. So we subtract 6.
3x.
First we subtract 6.
6.
Okay. So we have 5x equals 2x plus 6. That's right. And now we subtract 2x.
3x plus equals
So 3x equals 6. Divide by 3. Right? So x equals 2. So that's Maria now, right?
Yes.
So Nelson is 5 times 2, which is 10. That's how I solve it with algebra. They're trying to help you think it through without solving it with algebra, because you have the answers. Well, let's move on. Number 6. I think these ones with the sort of so-and-so is this age now and they used to be at that age later, those are some of the hardest word problems, I think. Let's do number 6. Which of the following is a solution? Oh, it's not even a word problem, it's just a quadratic equation, right? So the equation is 2x
X minus 15.
plus x minus 15 equals 0. And they give you a bunch of answers, so you just kind of plug them in and solve it to see if it equals 0 or not. So A, x equals minus 3. Alright, so we put that in. 2 minus 3 squared plus minus 3 minus 15.
Yes.
Right? Minus 3 squared is what?
9.
9. Because it's a negative, so it becomes positive when it's squared. So it becomes 2 times 9. This becomes minus 3, right? Plus minus 3 becomes minus 3
Yes.
minus 15. What is 2 times 9?
18.
18. What is minus 3 minus 15?
Minus 18.
Minus 18. Aha!
Equals 0.
Equals 0.
And this is true.
Solved. Lucky. If it's A, you're lucky. You don't need to do any more. Right? So you just go through like that. You could solve it. You want me to solve it to do some quadratic equation practice?
That's with
Good
the,
practice.
with
Good
that
practice.
law,
Pardon?
with the formula.
So, okay, I'll do it the way we've been learning and also with the formula. So, let's make some space. The first thing I'd say is I'm looking here. So this is going to be an x and a 2x, right?
Yeah.
So we're going to have a 2x and an x. Okay? Also, this is 15 and it's a minus, right? So it's probably 3 and 5, right?
Yeah.
It's probably not 1 and 15. So we're going to have 3 and 5 in some combination here. We need to figure out what, right? Because we have just x here,
Yes. 5.
right?
Yes.
So if it's 2x times 5 is going to be 10x,
Yes.
right? and a 3x, that's going to be a 7. That's probably not going to work. So let's try maybe a 3 will be a 6, and a 5 here will be a 1. So that's going to work. 5 and 3. Okay? And now it's positive. So these ones need to be positive, and then this one will be negative. So this will be now 6x minus 5x
Yes.
will give us x. And then this is negative 15. So if this equals 0, then, equals 0. So then 2x minus 5 equals 0, and x plus 3 equals 0. So for this one, x equals minus 3. This one, 2x equals 5, x equals 5 over 2. Okay? So that's how we do it, just kind of looking at the equation to solve it. What you do is, the big thing to know is that you look at the first and the last of this thing. And you know that these two multiply to equal the first one, and these two multiply to equal the last one. So you can figure out those two numbers, and then you just have to figure out what's the order and what's the sign. And you kind of figure that out based on what the middle one is. And it takes a little bit of just playing around with the options. Now you wanted to try the quadratic formula. Okay, so the quadratic formula was x equals minus b
plus minus.
plus, wait a sec.
Yes, it's plus minus.
Let me just check it.
I can help you with it.
Yeah?
Yeah.
Alright.
Yeah.
So there's a plus, oh, okay, it's all over. Yeah.
Plus
Got it.
minus
Square root
b squared
b squared
minus 4 ac
all
over
over
2a.
over 2a. That's
Yes.
right. Okay. So in this equation here, a equals 2,
Yes.
b equals 1, and c equals
minus 15.
minus 15. Okay, so then x equals negative 1, right, for b. I'll put them in brackets so we
b
1 plus or minus square root
yes
1
squared
squared
minus
4
times
times 2
yes times
times minus 15.
15
Okay?
over 2 there is over
2 times 2.
2 yes.
Okay, see, we just put each one.
Yes.
And remember, a is 2 because this is here a.
Yes.
B is 1 because here is 1.
One.
C is minus 15 because that's minus 15. Okay?
So now we're going with
Alright, now we have to solve it.
yes.
Okay, so let's see. This is minus 1 plus or minus. The big thing is what's in the square root.
Yes,
1 squared is 1,
Yeah.
right?
Yeah.
And what is 4 times 2?
Minus 8
Minus 8 times minus 15.
120
Yeah, so this becomes 30,
yes.
right?
Yeah.
Times 4 is 120.
Yes.
The negatives cancel. So it becomes plus
Plus
120.
yes.
All over 2
4.
times 2 is 4.
Yes.
Okay. What is, this is now,
121
yeah, equals negative 1 plus minus square root 121
yes.
over 4. What is the square root of 121? You guys
11.
know that? 11, that's right. 11 squared equals 121. Very convenient.
Yeah.
Because often in these you'll get like square roots, like long decimals and things.
Yeah.
Which would be the case. If you put like, if you just made up any numbers for these, you wouldn't get these nice easy solutions. You'd get the strange square root solutions with lots of decimals. Okay, so let me just move this over here. Alright, so that equals minus 1 plus minus 11
Yes.
over 4.
Yeah.
Alright, now we're going to split them up, okay?
Yes. Yeah.
So we have equals minus 1 plus 11 over 4, or minus 1 minus 11
Yes.
over 4. Okay?
Yes.
So this one, minus 1 plus 11
10
10
over 4
equals 10 over 4.
yes.
And this one, minus 1 minus 11,
Minus 12 is minus 3
or minus 12 over 4. Okay, so 10 over 4 becomes 5
5 over
over 2.
2.
And my solve
minus
is
3.
minus 3. And there we go. 5 over 2 minus 3.
Yeah. Here 5 over 2.
Mm-hmm.
If here x equal 5 over 2.
Yes.
We don't want to this to be 5 over 2. We need it to be 5 maybe.
Why?
So
This is fine. You can leave it 5. It depends. It depends on what's in the book. Right? It could be 5 over 2. It could be 2 and 1 over 2 as a mixed number.
Yeah.
Or you could put 2.5.
Because I reached up to here and then I found, I just leave it there.
Yeah. I prefer to leave my fractions as improper fractions like this because I can do more with them. Usually if I'm going to then do more equations, I have to convert it back into this format anyway.
Yes.
Because when it's like this, I can cancel and do all sorts.
Yes. When I came there,
Here?
x plus, I said there, I was written there, 5 plus 5 over 2 equals 0. And then I multiplied by 2. And 0 over 2 is already 0. And then there remain 5 plus x plus 5. And eventually I get x minus 5.
X minus 5. So I think you made a mistake in your calculation somewhere. Yeah.
Okay.
Usually what I try to do, I usually try to get like a constant on one side and the x on the other, and then you divide. And you can just leave that. Right? But all of this was not necessary for this problem. Right? This problem was just put this in.
Yes,
but I thought this is good practice to review how we did the quadratics. This is not, we're not doing it this way, but it's good to know the quadratic equation. Alright, very useful equation. And it's actually in your formula sheet. So you will get it here on page 413. It's the 5th from the bottom. On page 413, it's the quadratic formula. So that's actually, if you do have a problem on the test, where they give you something like this, and you cannot solve it, you can find your quadratic formula on your sheet and just use this. That's one way you can solve it. Now, this might seem a little complex, it's got a whole bunch of variables itself. So if you think this is harder than this, it's good to practice with both. So I'd suggest try practice using them both. Alright, so that's number 6. Let's do number 7. We've done the quadratic formula. Yes. 7. An amusement park sells adults and children's passes. Alright. The adult's pass is $25. The child's pass is $15. The group spent $450 on 20 passes. How many children's passes did the group purchase? Alright, so again we're going to do A. Let's do children's and adults, right? I guess it's the same. Yeah, adults, children's. Okay. No, actually the apostrophe goes here. It's a possessive of a plural. You guys remember this in English?
Yeah.
Right? So it's adults as children's, because the children is the plural.
Yeah.
So that's why it's apostrophe S.
Yes, because this one is plural and
Yeah,
yes.
the adult is singular, so adults is.
Yes.
Yeah, it's a bit weird. Alright, so anyway, it says the group spent $440 on 20 passes. How many children did the group purchase? So if they say 5, right? A is 5. Alright, so that means if children's was 5, how many adults? 15. That's right. And adults is 25. So it's 15 times 25. And a child's is 15, right? So we need to add, what's 5 times 15?
75.
So this is 75. And this one, we might need a calculator for that, right? So 375? Yeah, I think you're right. So we can say 20 times 15 is 300.
Yes.
So it's 2 times
300 is
Three.
75.
Yes, yes.
yeah, it's 30 and then 300. And 5 times 15 is 75. So 375.
Yes,
Okay, add that together. How much do we have?
550.
450.
450, sorry. Yes.
And says they spent 440. So it's not A. Not A. Okay, let's try B. B says 6. I'll bet you it's this one because this was 450, it was very close. Right? So even before I do it, I'm gonna guess it's this one. But let's go ahead and do it. Do you know why I was able to guess this one? Did you guys catch me? Because this came out to 450, right? And we're looking for 440. So it means it has to be something very close to this one. And the only other one is 6, so it's probably this one, but let's do it. Okay, so if it's 6, children's is 6, how many adults? 14. Times 15 times 25. So 6 times 15? You guys know what that is?
90.
Yeah, 90. 15 times 2 is 30,
Yeah.
and 6 is 2 times 3, so it's 30 times 3 is 90. How about this one? 14 times 25.
Yes.
360? So we can do 20 times 14 equals 280, right?
Yeah.
And 5 times 14 equals 70.
350.
because just we removed 15 from the
Wait,
375.
14 times.
In 5 you have.
Yeah, you're right, it is 360. So I'm trying to think what I did wrong here.
350.
No, because we're moving 25 from 375, not 15. Yes, it's 375, but each ticket is 25, so it's minus 25, so it becomes 350.
The first one.
Yeah. Because it's 25. The first one was 375, right? You have the right idea, it's a great idea. But it's not 15, it's 25.
25.
So each one is 25. So the first one was 375. So we remove 25 from 375, we'll get 350.
Yes.
Yeah. Okay, and this adds up to 440.
40, yes.
Alright, good, it's good. So we don't need to go on. So this is kind of like, it's not really, I'm not giving you like a formula and solve this out. It's kind of, you're just thinking with numbers. You're just kind of thinking mathematically to solve these this way. Any questions on this? You're just sort of saying, if it's this, I know what the other relationships are, so let me check them. And you follow through according to the different relationships. Any questions on this? Alright, the last one is number 8. Picture. I think in many ways this is the better way to do it for this kind of test. Because it's, they give you the answers already, and sort of when you do check it this way, you kind of know, yeah, I got it right. Because it worked out. So let's try number 8 here. A rectangular garden below is twice as long as it is wide. Okay. If the total distance around the garden is 120 feet, what is the width of the garden in feet? So what they mean by around the garden is from here to here is 120. right?
Mm.
It's what we call perimeter. We'll be learning that when we do geometry in a bit. So this whole thing is 20. All right. And we know this one is 2 times this one,
Yes.
right? So now let's try our different options. A is 15. And what is that one? It says, what is the width? So A says this is 15, okay? So if this is 15, then this is 15, right? And this is 30, and this is 30. So we add them all up. How much is it? 90.
90.
Total equals 90. Alright, so not A.
Not
Alright, B is how much? 20. B is 20. Okay, so we try with that. 20, 20, how much is this?
40.
40, 40.
120.
120. Total equals 120. Very nice, it's B. Cool. Okay? To do it algebraically, the way I would do it is I would say width equals x, length equals 2x, right? And x plus 2x plus x plus 2x equals 120. Right? So it's each one. 1, 2, 3, 4. So this is 6.
Yes.
6x equals 120. X equals 120 divided by 6,
20.
which is 20. That's how it's solved with algebra. Which do you think is easier, algebra or thinking through the problems?
This
You like,
one-
if
this
the
one-
algebra works
both-
for you,
Both of them is easy, but the rest, actually, algebra is, gives confidence.
Yeah.
Respond, I think.
you know it for
But
sure.
yeah, that one also is good.
So, for the test, whichever one you find the easiest to do, or you could try both ways if you have time and you don't feel confident.
Yeah.
As you practice, try them both. In the end, you're supposed to be learning the algebra,
Yeah.
right?
Yes.
We're wanting to teach you algebra. That's the whole point. So this is just like a trick to do well on the test. But sometimes in life, we also use tricks,
Exactly.
right? So it's not a bad thing to learn tricks. But if you want to learn, like, the math is here in the algebra. But this is good practice for thinking mathematically and just thinking about how you think about problems in the world. So I think they're both good.
Yeah.
But if you're wanting to I wanted to learn math, it's kind of the algebra is the way to figure it out.
Yes. This way, actually, we, in a, every day at work,
Mhm.
we face this kind of questions from people. And then
Yeah.
we, give them the answer.
Yeah, exactly. Like someone wants to buy, like they might come into a store and you're like the owner of the
Yes.
store, or the worker of the store.
Yeah.
They say, I want to buy fencing, and my yard has these dimensions, and you have to kind of like figure out with them how much fencing they should buy, and then they're like, there's a price to it. If you want this fence, it's only 165 per meter, or this fence, this is 365. It has this, and you can do the like calculations.
Yes. And
These
sometimes
things-
we put also things, and it's called shared light. The places where we put in Hebrew is called madaf.
Okay.
It's shapes like this one.
Yeah.
Then sometimes we put 1/1, dimensions,
Square.
there's width, length, and height. I know exactly how many pieces are there.
Yeah.
Then the people with me, they don't know. Even sometimes people, the people sent by the companies,
Yeah.
when they come, we want to make what is called, yes, mana. I
The-
know.
the order.
Yes, order. I know exactly what is needed.
Yeah.
You know.
Because you're kind of doing it in your head.
Every
You've been
day
learning it.
work, yes.
Yeah, exactly. This is practical, and this is the thing. Like word problems are hard, but word problems are the most practical of mathematics.
Yeah.
So it's good to know. It's good to know how to do this kind of conversion. All right, let's move on. So I want to do our lesson, and we still have the. I want to do some of those WhatsApp questions because we missed them last week. So we had better time today. So first, let's look at the next page. It seems like it wasn't too hard for you guys, right? This was pretty straightforward. Page 365. Yeah, so the idea of plotting the lines, and they had all these points, and you figured out where they were. It wasn't too difficult. All right, so let's just do. Yeah, we can do 11 and we can do 12 just to make sure we're on the same page. So if we look at number 11, it has on the coordinate grid below a line passes through points A and B. Let me try to draw it. Okay, this is y, this is x, and A is here, and B is here. And there's a line. Let me get that right. Passes through, right? And the question is, which of the following ordered pairs also lies on the line? Alright. So this kind of continues like this. Like this. You can think this is 0, right? 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6. So here we have, let's do the first one, A. A is 1 and 0. So 1 is here, and 0 is right here. So this is A. A is not on the line, right? B is 1 and minus 1. It goes down 1. So here's B. Does everyone agree with me how I'm plotting the points? The first one you go along the x-axis to find it. The second one then you go up and down from where you find on the x. Okay, so C is 0, so we go to 0. And then minus 1, which is this one here. C. And then D is x is minus 1 and y is 0. So here. Here is D. So which one is on the line?
D.
D. Mm-hmm. Is that, do you see that? Yeah. You just have to plot them. Plot each point. So the important thing is, like, every point it has an x and a y. So you first find the x along this line. So whatever the x is, the first number, and you stop there, and then you go along that dotted line up and down to find the y. Positive is up, negative is down. So this one, D, is minus 1. Hi, welcome. So minus 1 on x, you start at 0, you go down 1. And it's 0 on y, so it doesn't go up at all, it just stays here. And that's on the line. Any questions on that? Good, and let's try, that was number 11. Let me try number 12 over here. It gives us this triangle. Right? This point here. Point here. The point here. Right? That's 1, 2, 3, 4, and 2, 3, 4, 0, minus 1, minus 2. Minus 1, minus 3, minus 4. Okay. It says 2 of the corners are located at 3, minus 3, so 1, 2, 3, and minus 3. 1, 2, 3. That's this one, right?
3 minus 3.
And the other one is 2, 3, 2, and then 3, that's this one.
Yes.
3 minus
So what is the location of the third corner? So we find this one.
Yeah.
It's minus 3, minus 2.
Minus 3 minus 2.
Yeah,
Yes,
so it's
minus
A.
3 minus 2.
Minus 3, minus 2. I think you guys got that.
Yeah.
Right? Yeah. This part is fairly clear. You've got the plots, you've got the variables. Now we're going to be using it for putting algebraic lines onto a coordinate plane. So we're going to learn that today. But first I want to just go over those WhatsApp questions because we have some time.
Yes.
And then we'll do the graphing equations. Any other questions on this section though? Okay, great. You guys have got it. I'm glad to hear that. Just take a picture of that. Let's go back to those word problems from WhatsApp I gave you a while ago. So I'm going to look for it in here and try to forward it to the group again, just so that everyone has it. Let's see. Here it is. Okay, so everyone's got it there. So you should see that text.
Yes.
You guys want me to do all of them? Go over them all? Okay. So what's that time? Yeah, we'll stop a little bit through and we'll pick up after the break as well. Let's do number 1 of the WhatsApp questions. Everyone has them on the phone? You see them?
Yes.
Alright. So I sent it to the group, so it should be the latest picture. I just sent it now, so let's look at the old, do the most recent picture. Yeah, look at the most recent picture I sent. Yeah, click here. Scroll down. Yeah, that one. Yeah. Okay, so this is number 1. A company has K employees, where K is a whole number. You know what it means by whole number? It means it's not a fraction, not a decimal. Okay? And it's also a positive number. Whole number is a positive. Integer can be positive or negative. Whole is not a fraction, not a decimal, and positive. Okay, a bonus of $2,000 is divided evenly among all the employees. Write an expression to represent the amount each employee will receive in terms of K. Alright, so K is number, right? Employees. And a bonus of 2,000 is divided evenly among all the employees. So we have a total of $2,000
Yes.
among all. Yeah, among all K.
Even.
So it's divided among them, right? So we need to divide it by K. Okay? So each employee will get $12,000 divided by K. Okay? 12,000 over K. 2,000. Sorry. 2,000. 2,000. Yes. 2,000 over K. That's the answer. That's all it needs. Yeah. It's not asking for solving. This is like these problems that I gave you here, they're kind of like halfway in between. They're helping you get like expressions of things.
It's not correct K is equal to 2,000.
Pardon?
It's not correct.
To write 2,000?
Yeah.
No, it must be 2,000 divided by K.
You need to.
Because you need an expression that represents the amount each employee will receive
Even.
in terms of K. So that means K needs to be in the expression. And what you can think about it is if there's, say, 10 employees, right? And you're dividing 2,000 among them, each one's going to get 200, right? Which is 2,000 over 10. 2,000 over K. Now, do you see what I'm doing? I'm using the, like, messing around with numbers trick to check. She's like, okay, does this work? How does this work? If I have 10 employees, just come up with any amount, 10. And to get on, like, I know if I have 10 employees and there's 2,000 between all of them, each will get 200. So how do I get 200 from 10 and 2,000? I have to divide them. So it's 2,000 over k. So this is our answer. Okay? Let's try number 2. Number 2 says, in the past 2 weeks, the amount in a student's checking account has increased by $505. If the amount 2 weeks ago was X dollars, write an expression to represent the current amount in terms of X. So, pardon? What were you going to say?
X plus this number.
That's it. Yeah. These weren't meant to be too hard. They're just kind of, there's a lot of words, but it's just kind of, they're in between step for a word problem. So was
X plus 2.
X increased by 505. So now X plus 505. Okay, that's it.
Yeah, do number 1 and 2.
Yeah, number 1 and 2. All right. So we'll get to we'll do number 3 then. Let me just take a picture of that. Yeah, so these are just, when they say write an expression in terms of something, they just mean the variable is in it. Right? It's not an equation yet or anything like that, it's just the variables in it. So this one's X, this one's K. Let's try number 3. Ryan collects action figures. Do you know what action figures are? Little plastic toys of like Superman or something, little soldiers or something like that. So he collects action figures and adds 2 to his collection every month. If he starts with Y action figures, then in terms of Y, how many will he have in 3 months? So now, right, he has Y. And every month, we add 2, right? So in 3 months, how many have we added?
6.
6. So in 3 months, so what do we have now?
Y plus 6.
Y plus 6. Yeah. Just kind of think about it. Any questions on that? Yeah. Sometimes I think we look at it and it's kind of like there's this whole word problem and it kind of freaks you out. You just like stop and decompose it. What is it asking? What is it giving me? And you sort of write it down in more simple terms, and you can see sort of you can see the answer. We're gonna have a break now, and we'll come back and do 4 and 5. Okay? Okay, so let's start up again. We're on the WhatsApp questions. They're just asking you to write kind of algebraic expressions of the relationships that they're telling you. So let's see number 4. It says a cell phone plan charges $30 a month for a service plus 0.15, which is 15 cents a minute, for any calls. If Janelle makes a total of m minutes of calls in a month, what expression will represent Janelle's total bill in terms of m? Okay, so it's 30 for the month, right?
Yes.
It's asking us just in 1 month. So we start with 30, she's being charged 30, and then it's every minute is 0.15, right?
Yes.
Yeah.
And so that's m, so 0.15 m, right? Every minute. And we're starting with 30. So that's for calls. Overall plan. And the total is a combination of those, right? So just do 30 plus 0.15 M. I think that's it. It's 30 a month and 0.15 per minute. And we have this many minutes, so we multiply them. So like, for example, if she did 20 minutes, it would be 20 times 0.15 plus her charge for 30. So it's just the addition of these two. Any questions on that? The point of this exercise was building for doing full word problems, solving word problems. So these are like segments of the word problem. So you have like, this might be the half of the word problem, and then you need to solve for M. So it'll say like, in 3 months, she paid this much money or something like that.
But I can leave it like that, or
For this one, this is correct. Yeah.
like that?
They just want you to leave the algebra expression. Yeah. Yeah, because there's nothing else to solve here. There's no other things to solve. You just leave it as the expression. All right, number 5. A staple gun is used to secure fabric by placing a staple every n feet. Write an expression that represents the number of staples used to secure 20 feet of fabric. Place the staple every n feet. Right? So every n feet we have here. So we don't know how much n is, right? N could be 2 feet, it could be 4 feet, we don't know, right? But we do know the total amount of fabric.
20.
Is 20, right? So n is unknown, but we're putting a staple every n, right? And the total will add up to 20. So there's n inside the 20, right? So we want to know how many staples. So how many do we have inside? Basically, let's say, for example, let's say n is 4. Let's just imagine n equals 4, right? Just as a hypothetical. If n equals 4, then every 4 feet we put a staple, right? So how many staples would we do in 20? 5. So if n equals 4, how did we get to 5 from 20 and 4? We divided it, right?
20 over
So we did 20 over 4 gives us 5. So therefore, we don't know what n is, but in this equation, n was 4. So therefore, the expression is 20 over n. Do you see how I figured that out?
Yeah.
I was like, okay, I'm not quite sure what it should be, but let me just say, give a number for n. And if I know the number, then I sort of could figure it out in my head, just knowing what made sense. And then I thought, okay, well, how did I get that? I found the actual expression I used to get it, and then I put the variable back where it was. This is honestly, when I do these kind of word problems, this is how I do them. I like find a potential answer. I'm like, okay, if it were this, how would I get to that number? All right, now how did I do that? What's the math I used to do that? And then I solve it, and then I put it back as algebra, and I use it algebraically.
This is same like the first one, huh?
Pardon? This is like the first one, yeah. Yeah, where k was the bonus. Yeah, it's exactly the same. But this one was a bit harder to figure out. There was n over 20 over n. Because you have to think about what was happening in the problem, right? And every n feet, they put a staple until we get up to 20. So we're still dividing it by n. Actually, Malcolm, do you still have the remote? It is getting a little bit hot.
This one.
The air conditioning remote. Could you turn them on? We thought it was cold. Just maybe put them on 25 or something.
It's 24.
25?
24.
Yeah.
Now it's 4. We need 4.
It's
24.
24. It's okay.
It's good? Okay,
Okay.
just leave it, just leave it.
Okay.
Yeah. Okay,
Oh, you need cold or hot?
I'm hot. Are you
Ah,
cold or
yeah,
you
hot.
hot?
It is that
it's
17.
okay.
17 is
No, no,
fine.
no, no. If it's just on, it'll be fine.
Before
Yeah.
I score.
I'm
It'll
dancing
move
around
around,
the front. Yeah.
Yeah.
So I get hot. Okay. Any questions on this? How I solved it? Yeah? Okay. Then, oh, let me take a picture. Alright, so that's the review. Let's do graphing equations. So, we've already done the coordinate plane, right? And you guys were aces at that. Do you know what an ace is?
What?
You know what an ace? I said you guys are aces.
Yeah, excellent.
Ace in the, you know, the playing deck of cards? The ace is the highest card, the strongest card, right? So I say you guys are aces, it means you're really strong, you're really good.
Thank you.
So you guys are aces at the coordinate plane. You didn't even need me to do the review for it. So you're aces at that. So now we're going to go further with it, okay? Which is basically on this plane, you can put a line, and you can write the line as a algebraic expression of x and y. So this is y, and this is x. Okay? And what we can say is any line y equals 2x plus 1. Alright? This is a algebraic expression in y and x, and it describes a relationship between x and y. And the relationship will form a line on this plane. Alright? What it's saying is, what we can look at is on here, we can say if x equals 0, what does y equal? Okay? So here, y would equal, that's right, x equals 0, y equals 2 times 0 plus 1, which equals 1. So that means any coordinate set, any point where the x and the y satisfy this equation, they make the equation correct, that is a point on this line. So this is a 0 and 1 is a point on this line. So x is 0 and y is 1. Let's just do 1, 2, 3, 4, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. You kind of have to imagine the dots going out. So it's actually, the board does have it very faintly. And if you guys have, do you have graphing paper?
No.
No? If you can, either get some graphing paper, but on the books you actually have the graph there, so you can kind of see it on the graph. Or what you can do is you can kind of write with a ruler. Sometimes you can do with a pencil. So you do these ones thick, and then you do very light lines up and down if you want to make a chart to plot it exactly right with a ruler. Or you can kind of just sort of, you can see even from here you can kind of get it right. It may not be exact, but it'll be close enough. Oh yeah, here. Minus 1, minus 2, minus 3, minus 4. Alright, so we said one of the points on our line is 0, 1, right? So here's 0,
1.
and y is 1. So here's a point on the line. Okay, now we can try something else. Let's say, let's try, do this different thing. Say x equals 2, alright? So if x equals 2, y equals,
4 plus 1,
that's right,
5.
2 plus 1, y equals
5.
5. So therefore, 2, 5 is a point on this line. So we have 2, and we go 1, 2, 3, 4, 5. Oh. There's a point on the line. So once you actually have 2 points, you can draw the line, right? Because the line is anything that connects 2 points.
Minus 2 points.
That's straight. So you take your ruler. That's not going to work. And you draw it, right? If you have a longer ruler, you can draw a longer line. It basically goes like this, where you put little arrows on it. So I squeeze my points here. Because basically this line continues forever in these 2 directions. And what this is this here, y equals 2x plus 1. That is the equation for this line. So this is the algebraic way of writing this line here. And we can test some other things, right? So we can test what happens when y equals 0, right? So let me write it here. Y equals 2x plus 1. If y equals 0, we have 0 equals 2x plus 1. Right? So y equals 0. We'll say then negative 2x equals 1. So x equals negative 1 over 2. Okay? So I subtracted 2x from both sides. And divide by negative 2. So therefore, we have x is negative 1 over 2, and y is 0. So do we have minus half and 0? That's this point right here.
Yeah.
It doesn't look quite right because I didn't draw it quite right, but if I draw my line a little bit better, you'd see it passes through there. You can see other points, and sometimes you can maybe look at them. Let's see, minus 2, 3. Let's try x equals minus 1. Okay?
Yeah.
So if x equals minus 1, then y equals 2 minus 1
Y
plus
equals
1.
minus 1.
So that is minus 2 plus 1, y equals minus 1. Okay? So that means minus 1 is a point on our line. Yeah, that's about right.
Yeah.
Right there. You see? So all these points, they basically represent a relationship between x and y. That's why because it's variable, because it's not a single number, instead it's a relationship. It's saying whatever x is, y is this relationship to x. And so the way you plot a line is you find 2 points. And usually the easiest is you take 2 values for x, like I did, right? You take x equals 0, that's the easiest one. You start with x equals 0. Whatever it is, you start with x equals 0, you get a y, and that'll give you what the, it's actually called the y-intercept. It's the point at which the line crosses the y-axis, right? If x equals 0, it's wherever along this line here that this line will cross it. I'll write that here. This is called the y-intercept. Do you know what it means to intercept somebody? Right? If someone's walking and you cut them off, you stop them, you intercept. You come between.
To step him.
But you're kind of stopping him, you kind of come in between his, like in front of his way. So it's like it's sort of you're stopping him. It's like wherever it's sort of you cross in front of him, right? You can also be like they can encounter. Like if 2 ships are coming, they will intercept each other. It means they interact, they come. you could have two armies intercept and they have a battle. It's just like it's the coming together of two things.
Yeah.
So the y-intercept is wherever this line intercepts the y-axis. Okay? And the way to find it is you set x equals 0. Because the y-axis is x equals 0. Right? 0 here for x. So this is x equals 0. And it crosses, wherever this line crosses y is when you put x equals 0. So whenever you're trying to plot a line, the first thing you do is set x equals to 0 for the formula. And then the second thing you do is you can do another x, like x equals 2, or x equals minus 1, or something like that. And once you have 2 points, you can draw a line through them. You could say this is called the x-intercept, but we don't really use that one as much. We always do, because most of the equations are in the form of y equals something. We want to have y kind of by itself. Y equals something here. Okay?
Teacher,
Yes.
2x plus 1. This is a formula.
This is not a formula. This is an example of an equation of a line.
Okay.
I call it an equation because it has an equal. But up until now, we've done x something something equals 0. But now, we're plotting a line. So we're not wanting a single point, or 2 points maybe. We're wanting we're wanting the relationship of the line. So now we have y equals something something. Okay? Now, before when we did x plus this equals 0, it's actually we were looking for this point here, where y equals 0. But now we have the full equation, okay? And this basically just describes the relationship between the points. So I guess you could say an example would be, let's see, if you're like, you could even see it like in a, if you're walking up a mountain, okay? So you say like, for every 5 steps, or for every 5 meters you go straight, you go up 1 meter, right? So what that would say is, y, let's say, equals 1 over 5 x plus 1,000. Okay? Because you start at the height of 1,000, right? So that's representing where you start. If you imagine, and then you walk 5, 1, 2, 3, 4, 5, and you go up 1. You walk another 5, 1, 2, 3, 4, 5, and you go up 1. So then you see this line. That's, if you step back, that's what the mountain would look like. Right? But you don't start at sea level, right? If you did, it'd come down to here. But you're starting at like 1,000. So you're plotting it. I know if that kind of helps. There's like other things like that as well. We can talk about how the income of a company is increasing or decreasing. Now this is what's called a linear equation because it's a line. But we can have other kinds of equations which are like curved. One kind of equation is a quadratic equation. And that's where x is squared, right? We've been solving quadratic equations already. But you can plot a quadratic equation, and it means there's a curve. Or you can have more. You can x equals cubed. Or y squared and x squared. That's a circle. Or an ellipse. Some combination of those. And there's equations for all of these shapes. And so if you use, and you're talking about some graphing software that you're using.
Yeah.
The graphing software actually has equations for exactly how to make these shapes. And whenever you change some of the parameters, you change what's on x, or you change this, you change any of these numbers, it changes the shape
Yeah.
of the shape. But what they're doing is they're busy using this equation to plot that shape for you. So the computer has all those equations and just gives it to you, and you just change the parameters. So here you're learning the actual algebra the computer's using.
Yeah, it's really good.
Yeah. Okay. Let me take a picture of this and we can do some more. Another example. I'll try to keep my chart here. Okay, so say we have now y equals x minus 3. Okay? So the first thing we do is if x equals 0. Okay? So x equals 0, what does y equal?
Minus 3.
Minus 3. Okay. Yeah, because it's 0. So this is 0. And y equals minus 3.
0 plus minus 3.
Do you need me to explain that some more?
No, it's okay.
Yeah? Okay. So x equals 0, so we'll put 0 in here, so y would equal 0 minus 3. 0 minus 3 is minus 3. So 0 and minus 3 are our y-intercept, which means we find a point here, minus 3. So this is one of the points on the line. Okay? And then the next we can choose anything. We can say x equals 1. Or let's do x equals 2. X equals 2.
Y equal minus 1.
Y equals 2 minus 3, which equals minus 1. So we have 2 minus 1. Alright, so we go on here. 0, 1, 2 along the x-axis. And minus 1, right?
Yeah.
So we go down 1.
Yes.
So here's our line. Alright? This is not, let me write that more clearly. Minus 2, minus 1. 2 minus 1. Okay, so we have 2 minus 1. If you want, you could do a third point just to be sure.
Yeah.
Let's say x equals, let's do x equals 3. X equals 3.
Y equals 0.
Y equals 3 minus 3. Aha! So y equals 0. So that's the x-intercept. So that's here. X equals 3, y equals 0. We can see, yes, they are all in a line. If you wanted to plot it, you take your ruler, connect the points. Oops, my line's not very straight, but you get the idea, right?
Yeah.
So there's our line. Okay? Any questions on this technique? This is the basic way to plot a graph, an equation. Something you might have is you may have there may be a question that they ask you, something like y equals, remember we did 2x plus 1? Oh, no. They may ask you this problem. Y equals 2x plus 1. We have 0 and minus 1. Which equation does it on? Y equals 3x plus 1. Y equals x minus 2. Y equals 2x minus 1. And they'll say, which equation is this a part of? Pardon? C. You think B? So what you do is you say here is x equals 0. So we put here, if x equals 0 here, y equals plus 1.
1.
But this is a minus 1, so it doesn't work.
Yes.
Here, if x equals 0 here,
It's minus
y
2.
equals minus 2. Here, if x equals 0, y equals 1.
Yes.
So it's C. Okay? You'll get some problems like that. But you just solve it that way. These ones you don't actually use a graph. You just kind of use the point and put them in. Just remembering this is x and this is y, and you just have to make sure which one for these values will make this equation be true.
Yeah.
Okay? Right, now, and this, by the way, was called a linear equation. Because it's a line. You see the word line in here?
Yes.
So line R. Linear. Says linear, but it's a liner. It means a line kind of equation. I'll take a picture, yeah. Okay, now I want to teach you about the slope of a line. Alright. So, if you look at, remember our first one, we had y equals 2x plus 1 we had? And it was, I think it was y equals 2x plus 1, yeah? We had here, and here, and it kind of went like this. Do you remember? And the other one we just did was this one here, through this, right?
Yes.
And we could also do one that's like this one. So this is y equals x minus 3. We can also do one where y equals 1 over 2x plus 2. And that would be like here to here. Like that. Now I want you to see something. You see this one here is a much steeper
Yes.
line. And then this one is kind of like this, and then this one, the bottom one is less steep. Okay? And the thing that determines how steep the line is the value of x here. Okay? The bigger the value of x, the more steep the line. And this is what's called the slope. Alright? So if you're going up a hill, right?
Yes.
It's called a slope. And the steeper the hill, the more like the higher it gets per step,
Yeah.
right? The higher the slope.
The more difficult.
Yeah, the more difficult it is, right? If it's a very shallow slope, you're walking, you barely even realize you're going uphill.
Exactly.
If it's very steep, you can barely even walk it. Maybe you have to climb it to go up,
Yes.
right? So that's what this is, the slope. And the number in front of the x determines the slope. Okay? So what's interesting is we actually can figure out what the slope is, the slope of a line. Alright, so what you kind of imagine is the slope, we're going up here. What it's measuring is how far do you go across before you go up. So you go this much far up, across, you go this much far up. Okay? So this is what's called the rise, and this is the run. Okay? And slope is a measure of rise over run. Okay? So that means if for every 2 meters you go straight, you go up by 1, the slope, so this is 2, and this is 1, slope equals 1 over 2. Okay? Because the rise is 1, you go up by 1 for every 2 that you go. So you can see here, this one here This one has a slope. If I start here at -1, right?
Yeah.
And I go across 1, 2, right? How far did I go up? 1, 2, 3, 4. So I did, for going across by 2, I went up by 4. So my up is 4 and my across is 2. So the slope is 4 over 2, which is 2.
Yes.
P here, 2. How about this one? This one here. We start at -3, we go 1, 2, 3. We go up 1, 2, 3. So the rise and the run are the same.
Yeah.
I went 3 along,
Steps.
I go up by 3. So the rise over the run is 3 over 3, which is 1.
1.
You see here it has a coefficient of 1.
You go 1 step, you climb 1 step.
Exactly. Here, this one, we start at -4. 1, 2, 3, 4. We went across 4.
Yeah.
We went up 1, 2. So the rise is 2. The run is 4.
Half.
So it's half. 2 over 4 is half. And that's this one here. So in your equation, basically every linear equation has the form of y equals mx plus b. That is a formula that you need to know. Okay? And that is the formula, I think it's in your book. But this is the formula of an equation. Any linear equation, which means there's no exponents for x and there's no exponents for y. Okay? That makes it a linear equation. It's just an x and just a y. Any linear equation can be simplified to be written in this format. Okay? And m is the slope, and b is what? What do you think b is?
1.
So in this one, here we have 1, that's here, 1. Here -3, -3. Here's 2, here's 2.
That's why.
What is b?
Why?
The y-intercept. What that means is whenever you have an equation like this, you can instantly plot it. Because what you do is you take b, you put it here, and then you do a slope. So say this one, say we have x minus 3, right? So I find b is -3, so I do -3. And my slope is, for every 1 across, I do 1 over. So I do 1 across, 1 over. 1 across, 1 over. 1 across, 1 over. And I can plot the line. Right? This one here, 2x plus 1. b is 1, so I go here, 1. And the rise and run is 2 over 1. So for every 1, I go up by 2. So I can put this, I go across 1, up 2, put a point there, and I can plot the line. Every equation you can plot using this formula. You can also plot it the way we learned, with the 2 points. You choose any 2 points. But there will be a lot of questions asking you, what is the slope of the line? How do you find the slope of this line? And there's a way to do it. Okay? First, however, what about a line that's like this? Comes, let's see. This way. Right? We were doing lines like this. It's a bit confusing right now. Let me erase some of them. Erase this one too. Okay. So what about this line here? Right? These ones, when you move along, this one, right? You go along 3, you go up 3. But this one, say I start at 1, I go 1, 2, and I go down 1. So what that means is it's a negative slope. Okay? So positive slope means increasing line. A negative slope decreasing. Okay? So here, if this one is, we still have 1, but the slope is decreasing. So that means this line here is y equals, let's see, we have, for every, we go down 1, no, we go across 2, sorry, 1, 2, and down 1. So that means it's 1 over 2, right? The slope of the line, but it's negative. Negative 1 over 2x plus 1. Okay? So that describes this line here. The slope is negative, and the intercept is still the 1 here. Okay? Let me try another one. Let's go here. This line here. Okay? If I start at 4, I go 1, 2, 3, 4, and I've gone down 1, 2, 3, 4. So I go across and down the same amount. But I'm going down, not up. So what do you think the slope will be? Minus what?
3 over 3.
So
Minus 1.
3 over 3, which is 1. So the slope of this line is 1. And the intercept is 4. So that line is y equals minus x plus 4. This slope is the rise of the run, and b is the intercept. Okay? So what we're doing is you'll have some questions. Let me take a picture of that. And continue. You will have questions where they ask you what is the slope of a line. Let me erase these lines. Right, so you'll get a line, say a line like this. Didn't quite draw it properly, but you'll get a line like this, and they'll say, what is the slope of that line?
-1.
It's not negative because it's going up. When you go this way, it goes up. So it's like this way. From left to right, if it goes up, it's positive. If it goes down, it's negative. So it's a positive slope. And here we start at -2,
Yeah.
and here we have 2. Okay? So we've gone 1, 2 across, and 1, 2 up. -1 is positive.
1.
So it's 1. So the slope is 1.
But it's how? The slope is
So remember the slope
2 divided by 2.
rise over run, yeah?
rise
Rise
over run.
Yeah.
So the run is 1, 2, right? And the rise is 1, 2. To get from here to here, I have to go 1, 2 across and 1, 2 up.
But it's negative, eh?
It's not negative because it's going
Ah,
up.
okay.
Increasing.
Okay? So here it equals 2 over 2, which is 1. This one here, I'll do like this. Okay, we start at 1, right? We go across 1, we go down 1. Okay? So here we start at 1, run is 1, rise is -1. Because we're going down. So we're not rising, we're going down.
Yes.
0.
So it's 1 and -1. So here are the rise over the run. So this one, m equals 1. This one, m equals -1 over 1, which equals -1. Okay? There's another formula for the slope that'll help you figure it out. The slope is y2 minus y1 over x2 minus x1. So that means you can take any 2 points on the graph, y2, you can take x1, y1 and x2, y2. Okay? And the slope will be the y of the second one minus the y of the first one divided by the x of the second one minus the x of the first one. So take, for example, this one, right? Here we had 0, minus 2, and here we had 2, 0, right? Okay, so y2, so this, for this one, m, so 2, we had, what did I say? We had 0, minus 2, and 2, 0, right?
Yeah.
Those are the 2 points on this graph.
Yes.
So m here, y2 is 0. So m equals 0 minus y1. So minus 2. Okay? Divided by x2 is 2 minus
Y.
y1, x1, which is 0.
Yeah.
So that equals minus 2 is
Is
2 over 2
Yes, which is
equals
equal
1. So here's another formula for you. So this way, with this formula, all you need is 2 points on the graph.
Yeah.
Find any 2 points, and you can find m.
Slap, yes.
Alright? And then for b, you just find the point where it crosses the line. Okay? Now one thing is, if we don't know b, one of the ways we can get the full equation is that we have y equals mx plus b, right? So, say for example I don't know b. I only know these 2 points. I know 0, minus 2, and 2, 0. Okay? Now I have m, so y equals mx plus b. M I know is 1, so y equals 1 x plus b, which equals y equals x plus b. Okay?
Yeah.
But now I need to solve for b. So what I can do is I know these points. So I can put either one of these into this equation.
Yeah.
And I'll have b. So let's take this one, right? So 0, y is 0,
Yeah.
x is 2.
Yes.
2 plus b. Okay, 0 equals 2 plus b. So then minus 2 equals b.
Yes.
So therefore, now I know m and b. So y equals x, because m is 1, minus 2.
Yes.
And that's my equation. Right, so from 2 points, you can find the equation of a line. Using this formula and substituting in one of the points. Okay? These are the ways you find the formula of a line and the way you find a slope. And all the different questions will be based on some combination of those things. Let me do another example, and then we'll be done for today. Okay, so rewrite these numbers. Okay, so say you have a line here. Yeah, it goes like this. Okay? And they tell you you have the line goes through 1, 4, and let's see, it would be and -1, let's see, -2. So these are your points. Let's say here you have a line and it goes through these 2 points. Even before you plot it, you might just have these points only. Either plot the line, you can plot the line easily by pointing them and drawing it. Or find the equation either by plotting the line or by solving for the slope and the intercept. Okay? So plotting the line, I would put 1 and 4 and -2 here. I draw them through here. And I would see it crosses at 1. So my intercept is 1. And the slope is, I go across here 1 and 1, 2, 3. So the slope is 3. So I can tell just by plotting the line that it's y equals 3x plus 1. However, let's solve for it. Okay? So here, m equals -2, right? -4 divided by x2 -1 -1. Okay? Does everyone see how I got this?
Yes.
Yeah? From these 2 points using these formulas. Everyone see that? On board with that? Matt, you got that? Yeah? Okay. So -2 -4 is what?
-6.
-6. -1 -1? Over -2. -6 divided by -2 equals 3. So m equals 3. Okay? And now we need to find the y-intercept, the b. Right? So we say y equals mx plus b. So that equals 3x plus b. And we can take either of these. Let's take this one. So y is 4, right? 4 equals 3 times 1 plus b. Okay? So 4 equals 3 plus b. Subtract 3 from both sides. B equals 1.
1.
That's how I get 1 over here. You guys see that? It'll take some practice to get it. You'll have some problems to practice, and then we'll go over them next week. Okay? And I will also send you Khan Academy stuff if you want some more practice and more teaching. So here, the homework is page 367 all and page 369 all. Have a good week.
Thank you.